Hey everyone, today I'm going to show you how to find a critical value of a t-distribution given a confidence level and our sample size. Now this is going to be actually pretty straightforward. So if we know that our confidence level is 95%, then we know that alpha is going to be 1 minus 0.095 or 0.05, and we know that alpha over 2 is going to be 0.025, and this corresponds to the area in each tail of a t-distribution. So if we have this value over here, and this value over here, and this thing is going to go off, then the area in both of these tails is going to be 0.25, and put together that's 0.05. And for a standard t distribution, our t value is actually going to be 0. So this is going to be 0. And this axis is actually going to represent t. And t is going to be given by our sampling average minus the population average divided by the sampling standard deviation, but divided by the square root of n. So in this case, if we actually want to find the critical value for a 95% confidence level and a sample size of n equals 15, then we already have our alpha over 2, and the next thing that we need is the degree of freedom. So here, the degrees of freedom are n minus 1, which is going to be 15 minus 1, or 14. So it's going to be 14. Now that we have these two things, we can actually look up the value in a t-distribution or a critical t-table. So let's just pop that puppy in. And on the left side, we'll see that we have the degrees of freedom, and on the top, we'll see that we actually have the area in the two tables. And this is going to be our alpha value. So this one is going to correspond to alpha, and this is going to be alpha over 2. And you can look at either one of these, but we need alpha over 2, or alpha equals 0.05, and we need the degrees of freedom of 14. So we go to 14 over here, and then we go to 0.05 at the top, and we find their intersection, which is going to be 2.145. So our critical t value is going to be 2.145. Thanks for watching, and in the next video, I'll show you how to find a confidence interval using a t-distribution.